My name is Richard Sapp. What I emphasize in is tuberculosis. We're part of the TB elimination program here. I also happen to double as the 3D printer for the lab. I have 10 years of experience in the field. When COVID hit, the supply chain was hit especially hard. A lot of people that we work with regularly stopped being available to us. We encountered barriers that we couldn't overcome, things like 6-month, 8-month, 10-month lead times where you're not going to be able to get any supplies. The benefit of plastic supplies, which is something that we did run into issues with because polypropylene and a lot of other plastics were in high demand for use for PPE. So those supplies diminished rather quickly. Because of this, we had to start thinking about ways we could potentially procure those from other facilities locally or perhaps our own facility here. And that is how we kind of stumbled across this concept, which we got money for through the ELC grants, where we were basically going to source plastics internally. And what we stumbled across was we throwing away about 1,500 pounds of polypropylene, which is an autoclavable plastic, every year. It's something we had been doing for years, and it's something that laboratories across the country do all the time. We decided that it might be worthwhile, and we endeavored to get equipment to allow us to convert that 1,500 pounds of what was functionally trash to us into something that we could potentially use to assist us in providing testing. So as we developed this concept, we came into contact with a company called 3Devo, which is a Netherlands company. And they had equipment that would allow us to basically recycle, tear down, shred the plastics that we have, granulate them into a finer powder, and then convert them into a 3D printable filament. So the filaments that we had used for a few years prior to COVID, we could then potentially make in-house. The plastic we were running into issues getting was polypropylene, and the important part about polypropylene being it's autoclavable. Autoclavability is key to the medical industry because obviously we don't want to be getting people sick. Sterilization methods like autoclaving are pivotal. The plastic of most interest to us had to be autoclavable, and it had to be able to provide enough rigidity and performance for what we needed, our demands at the lab. And polypropylene number 5 kind of fit that bill. So we had 1,500 pounds of it. We have potentially an avenue that we can start creating a supply for ourselves that we can use. So now we're kind of in the midst of procuring that equipment, and we're in a very interesting time because we might, in very short order, be capable of producing spools and spools of filament for ourselves. When I say 1,500 pounds, that's quite a lot of plastic. So every spool that we buy is between 1 pound, about 500 grams, and 2.2 pounds, or about a kilogram. So half of a kilogram spool, or a 500 gram spool, approximately a pound, is $75 a pop. When you convert it from our 1,500 pounds that are currently waste to potentially 1,500 pounds of spools, that's about $100,000 worth of money made back. So it makes a lot of sense. We're in the midst of prototyping and printing shrubs containers that we can then use in the lab, and that will enable us to further benefit ourselves, not only in the ability to supply stuff for ourselves and have that reinforcement to our own network of supply, but also monetarily. It's less expensive for us to use what is currently considered waste than it is to buy them from the market. Now, the obvious issue is, are these going to be competitive with the ones that we're buying? And the quick answer is yes. We're going to be able to make them at least as strong, arguably stronger, and we're going to be doing so by matching ISO certified standards for sharps containers, which is a key element that we're going to be pursuing in the coming months. As this whole system matures, we're going to have a system of, not only production that we have in-house already, but we're also going to have a system of reclamation. And then as the ecosystem matures, we'll have a whole continuum of benefits that we can provide not only to ourselves, but also anybody who relies on the results, because they're going to be more reliable. So we won't be as susceptible to the disruptions that are basically we have encountered and others encounter, and we anticipate we will encounter again after this experience with the coronavirus.